One of the important reactions under alkenes is ozonolysis. So this ozonolysis reaction is used to identify the structure of that alkene, or especially to say where is the double bond located in the alkene. For example, if I take this alkene, which is butene, it can be 2 butene or 1 butene. How do we know whether whether that compound is 2 butene or 1 butene? We will perform the ozonolysis reaction, locate the position of the double bond, thereby determine the structure. So ozonolysis is a method to determine the structure by degradation. Degradation means breaking into smaller compounds. So let us understand the mechanism. Ozonolysis is of two types: oxidative ozonolysis, reductive ozonolysis. Mainly we use reductive ozonolysis. So first let us speak about reductive ozonolysis. So there is an alkene, C double bond C. All the 4 groups might be anything. It can be different carbon atoms or hydrogen. So first, when you are adding ozone, an unstable compound called mole ozonide is formed, which rearranges itself to another compound called ozonide. This is the mechanism that is happening. So you have to know these two compounds, mole ozonide and ozonide. But majority of the question will be based on what is the product formed, or where is the double bond present, or what is the alkene. They can give you the product and ask what alkene is formed. So in reductive ozonolysis, you use a reducing agent. The reducing agent can be zinc in the presence of acetic acid or zinc in the presence of water. So when you take this ozonide, that is this ozonide, or that particular alkene, and add ozone and add a reducing agent, then what happens? If there is a C double bond here, for example, I am taking this molecule and speaking, wherever double bond is there, break it. Instead of the double bond, put a double bond O, because this ozonide finally rearranges to the carbonyl compounds. So it undergoes a rearrangement like this and it becomes a carbonyl compound. So this will become a carbonyl compound. The other part also becomes a carbonyl compound. What is a carbonyl compound? It can be an aldehyde or a ketone. You have learned about carbonyl compounds in nomenclature already. Now, since this double bond has 2 carbons the other side and 2 carbons this side, it will form C-C double bond O, that is 2 carbons with double bond O and 2 carbons with double bond O. But if you look at this alkene, it has 1 carbon on this side of the double bond, 3 carbons on the other side of the double bond. So it will form 3 carbon atom carbonyl compound and 1 carbon atom carbonyl compound. So if I get 3-1 combination as the carbonyl compounds, then I will know double bond is between 3 carbon atoms and 1 carbon atom. If I get 2-2, then I will know the double bond is between 2 carbon atoms and 2 carbon atoms. So thereby, based on the products, I am able to assess where the double bond is present. So question will be, they will give you the products, ask you which alkene is this. Is it this alkene or this alkene? If they give you this products, you have to say it is this alkene. If they give you this product, you have to say it is this alkene. So carbon atom in the product help you to identify carbon atoms on both sides of the double bonds. So finally what you are able to do, you are able to locate the position of the double bond. That is the advantage of ozonolysis. Thereby you are determining the structure of the alkene. So that is to determine the structure. How? By breaking it into carbonyl compounds. That is the degradation part. This is ozonolysis reaction. Let us see few more examples. Suppose I am taking this compound, C double bond C. So this carbon has 2 hydrogens. So when this bond breaks here, double bond O is formed. So 1 carbon atom carbonyl compound is formaldehyde. This is 2 carbon atom carbonyl compound. This carbon atom still has a hydrogen. So it is forming a CHO structure. You can see that here. So if it is forming a CHO structure, this CHO structure will make it into an aldehyde. This also has a CHO structure, so that is an aldehyde. So CHO with 1 more carbon atom, it is acetaldehyde. Only 1 carbon atom, it is formaldehyde. You should know these names also, because in the options you will find them. Now let us look at this alkene. In this alkene, the double bond, on this side there are 2 carbon atoms, on this side there are 2 carbon atoms, but this carbon atom has 1 more carbon atom. Now have a look at the product. So this has a hydrogen. The carbon atom holding the double bond has a hydrogen. So this will be a CHO group, that means it will be aldehyde. It is nothing but acetaldehyde because 2 carbon atoms are present. Here, this carbon atom does not have a hydrogen, instead it has 1 more carbon atom. So this is R C and C on both the sides, or this carbon atom is R and R on both the sides. So this is nothing but a ketone. What is ketone? R C double bond O R dash. So this carbon is this carbon, this is R dash. So this is nothing but a ketone or an acetone. So whether aldehyde will be formed or ketone will be formed depends on how many hydrogens are present. If the double bonded carbon has a hydrogen, it will give an aldehyde molecule. If the double bonded carbon atom has no hydrogen but only carbons, that will give a ketone molecule. So this clarity is needed. Next comes the reagents of reductive ozonolysis. I already mentioned, to do reductive ozonolysis, reducing agent is added to ozonate. So the reducing agent can be zinc in acetic acid or zinc in water. So the summary is, for reductive ozonolysis will give carbonyl compounds. The carbonyl compounds can be aldehydes or it can be ketones. So that is the summary. So how will the question be given? An alkene will be given. They won't give the structure. They will give reagent 1 O3, reagent 2 zinc in the presence of H2. They can ask the products, which aldehyde and which ketone is formed. You should be able to answer based on the position of the double bond. So that is about reductive ozonolysis. Hope that's clear.